We now discuss the solution of a problem that appeared in the joint entrance examination main held on 27th June 2022 in the second shift. This question is from the section Complex Numbers and Quadratic Equations, and this question is on the roots of quadratic equations. The given question is, let alpha, beta be the roots of the equation x square minus 4 lambda x plus 5 is equal to 0, and alpha, gamma be the roots of the equation x square minus in brackets 3 under the square root of 2 plus 2 under the square root of 3 x plus 7 plus 3 lambda under the square root of 3 is equal to 0, where lambda greater than 0. If beta plus gamma is equal to 3 root 2, then in brackets alpha plus 2 beta plus gamma whole square is equal to. We are given two quadratic equations. This is the first quadratic equation and the second quadratic equation is here. And it is given alpha, beta are the roots of this first quadratic equation, and alpha, gamma and gamma are the roots of the second quadratic equation, where lambda is given to be greater than 0. Further, you are given beta plus gamma is equal to 3 root 2, then required to find the value of alpha plus 2 beta plus gamma whole square. That is the given question to us. Let us now discuss the solution of the problem in detail. Given alpha, beta are the roots of the first quadratic equation x square minus 4 lambda x plus 5 is equal to 0, where lambda is greater than 0. It is known that the sum of the roots alpha plus beta is equal to minus the coefficient of x by the leading coefficient, that is the coefficient of x square, and alpha beta is equal to the constant term by the leading coefficient. With that, alpha plus beta is equal to 4 lambda. Let's call that as the equation 1. Alpha beta, the product of the roots, is equal to 5. Let's call this as the second equation. We are also given alpha, gamma are the roots of the second quadratic equation x square minus in brackets 3 under the square root of 2 plus 2 under the square root of 3 x plus 7 plus 3 lambda root 3 is equal to 0, and alpha plus gamma is equal to 3 root 2 plus 2 root 3, following the same principle, that is the coefficient minus the coefficient of x by the leading coefficient, and the product of the roots alpha gamma is equal to the constant term by the leading coefficient, that is 7 plus 3 lambda root 3. This is the third equation. This is the fourth equation. Agreed. It is further given to us beta plus gamma is equal to 3 under the square root of 2. Call this as the equation 5. What is that we want? We want to find the value of alpha plus 2 beta plus gamma whole square. Now from equation 1 we have alpha plus beta. From equation 5 we have beta plus gamma. If you add these two things, you will get alpha plus 2 beta plus gamma. So adding 1 and 5, equation 1 and 5, alpha plus beta plus gamma is equal to alpha plus beta is 4 lambda and beta plus gamma is plus 3 root 2. So it is alpha plus 2 beta plus gamma is equal to 4 lambda plus 3 root 2. Let's call this equation 6. Now, if you square it, you will get alpha plus 2 beta plus gamma whole square, provided if you know the value of lambda. So, the problem reduces to find the value of lambda. Take that lambda, substitute here and square it, you will get your answer. So, our search is to find lambda. That we will do in the next slide. Now, those equations 1 to 6, what we have are here. Now we take the equation 1 and 5, subtract 5 from 1, then alpha plus beta minus gamma, beta cancels and you will get alpha minus gamma. So, from the equation 1, subtract the equation 5, then you will get alpha plus beta minus gamma, that is alpha minus gamma, is equal to, so alpha plus beta minus beta plus gamma, so that is alpha minus gamma, and that is 4 lambda minus 3 root 2. In the equation 1, 4 lambda is there. In equation 5, 3 root 2 is there. So, alpha minus gamma is equal to 4 lambda minus 3 root 2. Let's call this as the equation 7. We know alpha plus gamma from the equation 3. If we add, you will get 2 alpha in terms of lambda. And from that gamma also, you can get the values. So, let's see. So, 3 plus 7, equation 3 and 7. In equation 3, we have alpha plus gamma. In equation 7, we have alpha minus gamma. So, if we add, gamma cancels and 2 alpha is equal to 3 root 2 plus 2 root 3, that of alpha plus gamma, and plus 7. In the equation 7, 4 lambda minus 3 root 2 is there. 4 lambda minus 3 root 2. 3 root 2 cancels. You will get 4 lambda plus 2 root 3. This is 2 alpha. So, then alpha will be cancelled 2 throughout. We will get 2 lambda plus root 3. We will get 2 lambda plus root 3. Alpha value we got. So, go to equation 1 and obtain the value beta in terms of lambda. So, beta is equal to, from equation 1, 4 lambda minus alpha, that is equal to 4 lambda minus alpha is 2 lambda plus root 3, and 4 lambda minus 2 lambda is 2 lambda minus root 3. So, we got alpha in terms of lambda, beta in terms of lambda, and take the equation 2, alpha beta is equal to 5, and substitute alpha beta, then you will get the value of lambda. Right, that's the plan. Therefore, go to the equation 2, where you have alpha beta is equal to 5, alpha is 2 lambda plus root 3, beta is 2 lambda minus root 3, multiply is equal to 5. This is 4 lambda square minus 3 is equal to 5. This will imply 4 lambda square is equal to 8. This will imply lambda square is equal to 2. Therefore, lambda is equal to plus or minus root 2. But lambda, in equation 1, you can see lambda is given to be, in the hypothesis, it is given to be lambda greater than 0. Therefore, minus root 2 is discarded and we get lambda is equal to root 2. Right. We got lambda is equal to root 2. Go to equation 6 and substitute the value of lambda and square it. So, from 6, alpha plus 2 beta plus gamma is equal to 4 lambda plus 3 root 2. But lambda value is root 2. So, 4 root 2 plus 3 root 2, and that will be 7 root 2. Square it. Alpha plus 2 beta plus gamma whole square is equal to 7 root 2 whole square. That is 7 sevens are 49 into 2, that is 98. That's your answer. So, the answer to this question is 98. And that is the detailed discussion of the solution of the problem, which is based on the properties of the roots of quadratic equations. and the question is from the section complex numbers and quadratic equations. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.